All right, we are on topic 2, block 7 in your math book. Let's find out what page that is. Topic 2, block 7 begins on page 59 in your math book, page 59. So you can turn there with me right now. All right, question number 1 says that Mallory works at a local coffee shop, and last week she worked 22 hours and 30 minutes and earned $258.75. So what does Mallory earn per hour? So that's what we're looking for. We're looking for her hourly rate. So we're looking for a unit rate. So let's see if we can figure that out. The information that we have is that she worked 22 hours, 30 minutes, and she earned $258.75. So the money that she earned per hour. Remember what I said about the word per? That is going to be our fraction bar, our division line. So we're looking for the amount of money that she earns per hour. Now, let's think about this. If we're looking at, this says that she worked 22 hours and 30 minutes. We need to convert that to just hours. We know how much money she made. She made 258. Whoops, hold on. Sorry about that. 258, 75, and 22 hours, 30 minutes. We need to convert that into just hours. So what would that be in just hours? Hold on here. Here we go. Let me see if I can bring that back up. Okay. Well, 22 hours, 30 minutes. So you have to ask yourself, how many minutes are in an hour, right? Because we're looking at 30 minutes out of an hour. So if you have 30 minutes out of 60 minutes, because there are 60 minutes in an hour, then 30 divided by 60 is 1/2 or 0.5. So when we're looking at this, if you have 22 hours, 30 minutes, then you have 22 hours and a half an hour, 22.5 hours, right? But what we want to know is, what does she earn per 1 hour? So we have to take that 22.5 and we're going to divide by 22.5. Or, multiply by the reciprocal, which, whatever. But we have to, whatever we do in the denominator has to be done in the numerator as well, if we want to keep things fair and balanced. So $258.75 divided by 22.5 works out to be, my calculator says 11.5. But since we're talking about money, we've got to tack on that extra zero. So $11.50 per hour. Per hour is how much money Mallory makes while she's working at the coffee shop. Okay. Now, the next question asks us to write an equation that relates the hours that Mallory works, represented by the letter X or the variable X, and the amount that she earns, which is represented by the variable Y. So let's write that equation. Okay. So the amount of money that she earns is going to be equal to $11.50 multiplied by, right? Multiplied by the number of hours that she works. And in this case, that's X. So we don't need that multiplication dot. So we can just say, well, the hours that she works is going to be equal to 1150 X. That's our equation. Now we know that this will work because if she works no hours, like 0 hours, she'll make $0, right? So if we're And if we're continuing on with this, the rest of this question, the rest of the question asks us to say that if she worked 20 hours, 45 minutes, 20 hours, 45 minutes, how much will she earn? Well, 20 hours, 45 minutes. How much, what part of an hour is a fraction? This is on page 59. Page 59. 1150 multiplied by x. Well, 20 hours, 45 minutes. Well, the 20 part's easy, right? But let's look at 45 minutes. What part of that is an hour? Well, if you're talking about 45 minutes out of 60 minutes, 45 divided by 60 works out to be 0.75, 3/4 of an hour. So if we take this equation here now we know how many hours she worked. She worked 20.75 hours. So we can go over here and say, all right, well, there we go. Y is equal to 1150. That's how much money she earns per hour, multiplied by 20.75 hours. Well, that's pretty straightforward. $11.50. Multiplied by 20 hours and 3/4 of an hour. All right. It tells us that Y is equal to 238.625. Well, there's a problem with that because Y is supposed to represent the amount of money that she makes, right? And we've got 3 places after the decimal here, and we can't if we're talking about money. So Y is going to be 238. And then we have to round the 0.625. And anybody that knows anything about rounding knows that this 5 next to the 2 is going to tell the 2 that it needs to round up to the 3. So it's $238.63. That's how much money she will earn. So we came up with the equation and we figured out how much money she'll make if she works that many hours. The great thing about coming up with the equation is you can put in any number of hours and you have the amount of money that somebody could make based on their hourly pay. Okay, so now question number 3 says that we found the unit rate that compares dollars earned per hours, right? So we did this. We did dollars per hour. That's what we've done. There's another unit rate that we could use for this relationship, right? Remember, with a ratio, there are 2 unit rates. And so the other unit rate that we would look at would take the hours and look at compared to the money. So hours per dollar. So what does this unit rate mean? Well, this, of course, if we look at this is saying, well, we can find out how many hours she would have to work to earn a certain amount of money. So that's interesting, right? The how many hours she would work to earn a certain amount of money. So let's look at that. Now we already know that she worked 22.5 hours. And during that time, she earned $258.75. But let's turn that into how many hours does she have to work to earn $1, right? $1. How much time would she have to work? Well, remember, we've been doing this, and I think by now you can recognize that all we have to do is perform this division right here. 22.5 divided by 258.75, and we get the number that's going to go over our 1. And in this case, 0.0869. Ooh, okay. 0.0869 and so on. Let's round that down to the nearest hundredth. Okay, let's make life a little bit easier. So we're going to take this amount and say, all right, well, that is actually rounding it to the nearest hundredth would be 0.09 hours per dollar. So for every dollar that she works, or sorry, every dollar she earns, she has to work 9/100th of an hour, 9/100ths of an hour. But that is the constant of proportionality right here for that scenario. 0.09 is the constant of proportionality, the COP. And that's important information to know. Okay? When do you multiply by the reciprocal? All right, so the next question is, how many hours would Mallory have to work in a day to make $46? Oh, use an equation to answer this question. Well, there are a couple of equations that we could use. We have this one. Remember, there was the amount of money that she makes is equal to 1150 times X, right? And so if we want to make $46, all we'd have to do is substitute the amount of money she makes or with the 46 and write the rest of the equation out like that, and then solve for X, because X is the number of hours that she works, right? So we could divide that by 1150. Now, these two 1150s would cancel out, and 46 divided by 1150 equals 4. So X equals 4. Right? That's one way to take a look at this. But let's look at what we just figured out here, right? 0.09 would be the constant of proportionality for this other situation. So let's look at it this way. The number of hours that she would have to work would be equal to 0.09 multiplied by the amount of money that she wants to make. So we would rewrite this as X is equal to 0.09 multiplied by that 46. Now, we might come up with a slightly different number, but I don't think so. 0.09 times 46. It comes out to 4.14, so pretty darn close. The number of hours, 4.14. We'd have to round that down to 4. Because, 0.14 hours, are you kidding? Crazy. So yeah, either way, there is a way to figure this out. You can use either equation, but you can see that the constant of proportionality is slightly different in each one of them. Here, the constant of proportionality is right there. And here, because the roles were reversed, the constant of proportionality is 0.09. It just depends on what you're looking for. Okay. All right, so let's take a look at this question right here. For each scenario, find a unit rate and write an equation that relates the two quantities. Make a table of 4 values and sketch a graph of the relationship, then identify the constant of proportionality. There's that constant of proportionality again. So what we want to, let's focus on 2 things here, 2 things. Let's focus on the constant of proportionality, all right? And We want to make sure that we write that equation. Okay, so you can see she earns $66 for 8 hours of work. So we are comparing the amount of money to the number of hours that she works. Okay, so that's $66 divided by 8 hours. So 66 divided by 8 will give us our constant of proportionality. Now, I want to make sure that you have the same numbers in your book that I have in mind. 66 for 8-hour shift. Yeah. So this means she makes $8.25 for 1 hour of work. That's our constant of proportionality. Okay. That is the COP, the constant of proportionality, the 825. Now, if I wanted to write this as an equation, well, then my equation would be the amount of money that she makes is equal to $8.25 multiplied by the number of hours that she works. So if I wanted to make a table of this information, it would be easy enough to do. Here's my X, here's my Y. 0 hours, 0 money. 1 hour, $8.25. 2 hours, $16.50 because I just multiplied 825 times 2. Okay, 825 times 3 for 3 hours would be $24.75. All right, and then I could make a graph of that information and put it here. These are the number of hours that she works. And this is the amount of money that she will make. And that graph, the line of that graph, had better be a straight one, and it had better pass through the origin, because if she works 0 hours, she's going to make 0 money. So make sure that your graph and your table, so you've got to do this, you got to do this, you got to come up with the constant proportionality, and you'd better come up with the equation. And this right here, this equation, that's your proportional equations are always going to look exactly like that. The only thing that will change will be the constant of proportionality, because your output will always be equal to the constant of proportionality multiplied by your input. Now, don't go anywhere just yet. Hang on tight. I've got something to give you in the chat. Dun, 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 dun. I know that we're running short on time, but don't worry. I got this. All right, let me find my chat. Where is it? There it is. I'll make sure everybody gets this. That way you'll have a head start. There you go. This is the link to the forms document for this lesson.